Hello. Today we are going to take a look at the Part A Inequalities Review. Your assignment is only to do the evens, but it may not be a bad idea to jot down some of the notes and examples. So let's jump right in. I just want to review that we use an open circle for the less than or the greater than symbol. Let me change colors. And we use a closed circle for a less than or equal to or a greater than or equal to symbol. Okay, so if we take a look, I have all of the odds completed. So as we go through, if you want more practice or if you think you need a little bit extra help in certain types of problems, do the odd numbers and then come back to this video and check them out because the answers and work are all there. But for right now, we're going to focus on the evens here. Number 2. We're asked to graph the following inequalities on the number line. So I take a look at x is greater than -1. Since it's a greater symbol, I'm going to use an open circle right at -1. Open circle. And if x is greater than -1, we'll have to think of where are my numbers that are greater than -1 on my number line. They're the ones over here. So I'm going to shade in. Therefore, I can plug any of these values in for x, and they would be true statements. So let's choose 6. 6 is greater than -1. True. Awesome. Looking down at number 4, I would read that as x is less than or equal to -5. So I have the less than or equal to symbol, so it's going to be a closed circle where? At -5. All right, -5, let x is less than or equal to -5. So where are the numbers that are less than -5? Down here. And I can plug that, any number in for it. Is -8 less than or equal to -5? Yes. And if you recall, we can use -5. That could be a solution. That's why it's a closed circle. -5 is less than or equal to -5. So that works as well. Now, number 6 and 8 says write an inequality given the graph. So, taking a look at 6, well, x is, well, these are my solutions. How are they related to 4? They are greater than or equal to 4, closed point. Taking a look at 8, this number here is -3. So how is x related to -3? Once again, all of my solutions are up this way. Those numbers are greater than -3. All right, so now that we have worked on graphing and writing the inequalities with one variable, we're going to talk about solving inequalities. So just a couple rules. You must flip the inequality symbol when you multiply or divide by a negative number. So again, you'll see some of my examples done, and I literally write out flip inequality when I see that negative. So if we take a look at number 10, we're going to pretend this is an equal sign and undo those order of operations. So we work at those order of operations in reverse. So addition or subtraction first? Yep, I have addition. So I'm going to get rid of that 2 by subtracting 2 on both sides. So now I'm left with x divided by 6 is greater than -3. And how am I going to get x by itself? Well, if it's being divided by 6, I need to multiply by 6. Right, so those cancel whenever I multiply on the left-hand side. I must do that on the right. So now I have x is greater than -18. Notice I did not flip the sign, or the symbol, because 6 was positive. If that was negative, which you'll see in a few problems, then you flip the inequality. Doesn't matter if your answer is positive or negative. It matters that this number is negative. All right, so x is greater than -18. When we go to graph, I really care about 2 numbers here. I care about where is -18 and where 0 is. X is greater than -18, which means all of the solutions that would make that inequality true would be this way. You can test it out. Is 0 greater than negative 18? Absolutely. All right, moving on. Number 12. So it's set up very similar to number 10. Two-step inequality here. I want to undo that addition or subtraction first, and I have a negative 5. So I'm going to get that to 0 by adding 5 to both sides. So I have x divided by negative 8 is less than 3. All right, and now to get x completely by itself, well, if it's being divided by negative 8, I must multiply by negative 8. Oop, I multiplied by a negative, which means that this inequality is no longer less than, it's going to flip to greater than. So x is greater than negative 24. When I go to graph, I really care about where my 0 is and where my 24 is. Greater than, open circle. Where are the numbers that are greater than negative 24? This way. And again, I can test it out. We can plug 0 in. Is 0 greater than negative 24? You bet. All right, let's move down to number 14. There's number 13, in case you want to try that. Number 14, I need to get rid of that positive 3 first. It's a positive. Don't look at this symbol. No, look at the symbol in front. And if you want to write it in, it's a positive 3. So let's subtract by 3. Negative 4x is less than 28. Well, negative 4 times x, I'm going to undo that by dividing by negative 4. Holla, I just divided by negative 4, which means I need to flip my inequality, which I did forget to write up here, so I'll write it in real quick. All right. You don't always have to write it in, but I sometimes do, just to reinforce that idea that I have to flip that inequality when I multiply or divide by a negative. All right, so back to the problem. Negative 4 divided by negative 4 cancels. X is less than negative 7. So let's graph it. 0, negative 7. I don't care where you put negative 7. You can put it here, you can put it here, you can put it here, but you cannot put anywhere up there, okay? So, x is less than negative 7, less than open circle. Oh, I forgot to flip it. I wrote down the flip, so let's rewrite the answer. X is greater than negative 7, and all the values that are greater than negative 7 are to the right. And we can test that out. Is 0 greater than negative 7? Yes, it is. All right. On to 16. Here we go. A couple more. So again, undo that addition or subtraction first. I have that negative 1. Let's get rid of it and move it over here with the 14. So I now have negative 5, 6x is greater than or equal to 15. Now here, you can, it says negative 5, 6 times x. We could do two things. We could multiply by the reciprocal, right? When you divide a fraction, keep, switch, flip. In other words, multiply by the reciprocal. Okay, so you could do this and get the answer because these would cancel completely. Or feel free to break it up into 2 steps. I'll show you that way. I multiplied by the reciprocal over here. Okay, but I'll break it up into 2 steps with this problem with 16. So first I'm going to look, I have something is being divided by 6, so I'm going to multiply it by 6. We'll keep the negative with the 5. Great, those cancel. I now have negative 5x is greater than or equal to 90. Now I'm dividing by -5. Since I'm dividing by a negative, I must flip my inequality. So I have x is less than or equal to -18. All right, so I have 0, I have my -18. Closed point, because it's x is less than or equal to -18. My solutions are to the left. And if I want to test something out, well, -20 might be down here, or will be down here. So is -20 less than or equal to -18? Yes. Let's look at 18. All right, here's my x. Can't get there yet because I need to, get rid of that 6. Ask yourself over -6. Don't worry about what's behind it. Worry about what's in front of it. It's a +6. So let's subtract the 6. Carry this negative, or the subtraction symbol down as -x is less than or equal to 8. While -x is really, I can change colors here, it's a -1x. Divide by -1, x is less than or equal to, whoa, not less than or equal to, it's a negative. I must flip. Greater than or equal to -8. All right, down to our number line, 0, -8. Closed point, closed dot, closed circle. X is greater than or equal to -8. Where are the numbers that are greater than or equal to -8? Right over here. We can test that with that 0. 0 is greater than or equal to -8. True. All right. And number 20. We're going to look here because right away we have the quantity x plus 11 divided by -2. Well, I can't do anything when something's inside parentheses. And even though I just drew them in, when you have an expression in the numerator, you have to imagine they're grouped together. So whether or not you see the parentheses, you can't do anything with the numerator until you deal with this denominator. So if it's being divided by -2, immediately I have to multiply it by -2. And those same rules still apply. I now have x plus 11, and I just multiplied by a negative. So I'm hoping you already have the flipped symbol down. So x plus 11 is greater than 4. I'm going to subtract 11 from both sides, and I'm going to get x is greater than -7. Down to my number line. Where's 0? Where's -7? Greater, open point. Well, where are my values that are greater than? Over here. So I can always double check. 0 is greater than or equal to -7. True. So this is your Part A inequality. Part A inequalities review. Okay, you did learn this in Part A last year. Writing inequalities with one variable, graphing inequalities with one variable, and solving inequalities, two-step inequalities. So hopefully you did well, and I will hopefully see you soon. Bye.